Hi friends, today I am giving a lecture on Hamming code. Hamming code is one of the most important concept in error detection codes. It is one of the error detection technique. Hamming code is a error detection technique developed by R.W. Hamming to detect errors in the given message. Hamming code is mainly used for detecting single bit errors. It cannot detect multiple number of errors. Suppose we can take a message. The source can send a message by adding some number of parity bits or redundant bits and insert these parity bits at particular position in the given message to accomplish error detection and correction process. Okay. What are the main applications of Hamming code? The main applications of Hamming code is used in satellites, modems, and computer memory. In these three applications, we have to use Hamming code. Okay. Next one, the process of encoding a message using Hamming code includes the three steps. The first step is calculation of total number of parity bits. How to calculate the total number of parity bits that we have to add in a given message when the message contains m number of message bits. Okay, here P is nothing but number of parity bits. So the parity bits or redundant bits we have to add in the message. Okay, how many number of parity bits that we have to add for a given message by satisfying this formula 2 power p greater than or equal to m plus p plus 1. Here m is nothing but number of message bits, p is nothing but parity bits. So 2 power p greater than or equal to m plus p plus 1. If the condition is satisfied, then p is nothing but number of parity bits that we have to add. Okay, once the p value is calculated by using this formula, so then total number of bits is equal to m plus p. M is nothing but number of message bits, p is nothing but number of parity bits. Okay, in this first step, calculation of total number of parity bits. Okay, in the given message, only the total number of message bits can be denoted by m. Okay, the total number of parity bits that we have to add for a given message, so calculated by using this formula 2 power p greater than or equal to m plus p plus 1. If this condition is satisfied by knowing the m value, then we have to calculate the p value. Once p value is calculated, then the total number of bits is equal to m plus p. Okay, next one. Once we are calculating the how many number of parity bits that we have to add for a given message, now we have to place the parity bits in their correct positions. Okay, so p parity bits can be placed at bit positions of powers of 2. Powers of 2. Here p1, p2, p3, p4 are the parity bits. Okay, P1 P1 is located at 2 power 0 position and P2 is located at 2 power 1 position. P3 is located at 2 power 2 position and P4 is located at 2 power 3 position. Only parity bits are located at bit positions of powers of 2. Here 2 power 0, 2 power 1, 2 power 2, 2 power 3. Only at powers of 2 positions we have to place the parity bits. Okay. Next, the remaining positions, that are third position, fifth position, sixth position and seventh positions, we have to place the message bits. Okay. Now, how many number of parity bits are there? There are 4 parity bits are there. How many number of message bits are there? 4 message bits are there. Total number of bits is equal to m plus p. M is nothing but 4 and p is nothing but 4. 4 plus 4, that is equal to 8. So m plus p is nothing but 8. Okay. So here how we are getting? Here m is equal to 4. Number of message bits is equal to 4. Then how to calculate the number of parity bits required? 2 power p, so greater than or equal to 4 plus p plus 1. Okay. Suppose p value we have to take 3. So 2 power 3 greater than or equal to 4 plus 3 plus 1. So that is 8 greater than or equal to 8. So this condition is satisfied. Now m is equal to 4 and p is equal to 3. So in this way we have to calculate the total number of parity bits that we are required. So now m plus p is equal to 7. 4 plus 3, that is equal to 7. Once we are getting the how many number of parity bits, that parity bits are placed at 2 powers positions, 2 power 0, 2 power 1, 2 power 2 and etc. Okay. Next one. Third one, calculating the values of parity bits. Once we are calculating how many number of parity bits are there, once we have to find out these parity bits are located at powers of 2 positions, then how to calculate the parity bit value. Okay. So before going to that, the parity bits makes the number of ones either even or odd. Okay. Once we are adding the parity bits to the message bits, the total number of ones may be either even or odd. Okay. So here there are 2 types of parities are there. One is odd parity and second one is even parity. Odd parity is nothing but the total number of ones in the given message, so is even, then it is called as a even parity. The total number of ones is odd, then it can be called as a odd parity. Okay. If the total number of ones is even, then it can be called as a even parity. The total number of ones is odd, then it can be called as a odd parity. Okay. Once we are find out the odd parity and even parity, okay, then how to calculate the parity bit value? The parity bits calculated by using this example. Suppose a given message is equal to 1010. So therefore number of message bits, how many number of bits are there? 1, 2, 3, 4. Therefore m is equal to 4. Number of parity bits required is calculated by using this formula, 2 power p greater than or equal to m plus p plus 1. Here we know only the m value, m is equal to 4. After substituting m value 4, so based on the condition, we have to calculate the p value. Suppose p value we have to take 3, 2 power 3 greater than or equal to m value 4, p value 3 plus 1, 8 greater than or equal to 8. So that is true. So therefore, number of parity bits P is equal to 3. Next, total number of bits is equal to number of message bits plus number of parity bits. Here message bits is 4 and parity bits is 3. So 4 plus 3 is equal to 7. So now here these 7 bits can be represented in this way: 1, 2, 3, 4, 5, 6, 7. Now parity bits are located at bit positions of powers of 2. Powers of 2 is here, this is 2 power 0. 2 power 0 is equal to 1. Next 2 power 1. 2 power 1 is equal to 2. 2 power 2. 2 power 2 is equal to 4. But here 2 power 3 is not there because 4 plus 3 is equal to 7. Total number of bits. Okay. Here at 2 power 0 position parity bit P1 is there. At 2 power 1 position parity bit P2 is there. At 2 power 2 position parity bit P3 is there. Next the remaining bits, so the message bits we have to insert, that is M1, M2, M3, M4. Here M1 value LSB side, that is 0, and M2 value is 1, and M3 value is 0, and M4 value is 1. Okay, so this is LSB and this is MSB. Okay, based on that we have to insert these values. Now we have to calculate the parity bit P1 value, parity bit P2 value, parity bit P3 value. Okay, so here there are 7 bits are there. So 7 bits can be represented as 0, 0, 1, 0, 1, 0, 0, 1, 1, 1 0 0 1 0 1 1 1 0 1 1 1. So this is the decimal equivalent of 1, decimal equivalent of 2, decimal equivalent of 3, decimal equivalent of 4, decimal equivalent of 5, decimal equivalent of 6, decimal equivalent of 7. Now parity bits are calculated. Parity bits P1, P2, P3 are calculated as okay, first we have to take P1. So P1, while you are calculating P1, okay, we have to consider the LSB, least significant position, where the 1 is there. Okay, here 1 is there at 1st place and 3rd place and 5th place and 7th place. Okay, so now consider this. While calculating P1 value, we have to consider the LSB position column. In that LSB position column where the 1 is there. Here 1 is there at 1 is there in this position, 1 is there in this position, 1 is there in this position, 1 is there in this position. 1, 3, 5, 7. Okay. So now at 1st position, what is the value is there? Here P1 is there. Okay. Next at 3rd position, what is the value is there? 0 is there. At 5th position, what is the value is there? That is 1. Next at 7th position, what is the value is there? That is 1. Suppose the given message is sent with even parity. The given message is sent with even parity. Okay. So based on that even parity, here what is the value of P1? Okay. Suppose in this message P1 0 1 1, how many number of ones are there? 2 ones are there. It is already even parity, so that P1 is equal to 0. So therefore 0 0 1 1. So this is a even parity. So therefore P1 is equal to 0. Okay. So now calculating P2. So P2 is equal to, now consider the next column after LSB column. Next we have to consider this column where the ones are there. So the one is there at second position, next third position, next sixth position and seventh position. Okay. So now in the second position, what is the value is there? That is P2. Next, in the third position, what is the value is there? 0. In the sixth position, what is the value is there? 0. In the seventh position, what is the value is there? That is 1. Okay. To become this message even parity, what is the P2 value? If the P2 value is 1, then two ones are there, then it becomes a even parity. So therefore, P2 value 1, 0, 0, 1. So then it becomes a even parity. Why we are taking even parity? The message is sent with even parity. So because of that reason, the total number of ones in the given message is even number. Here only one single one is there. To become this message is sent with the even parity. So P2 is equal to 1. Okay. To send this message with the even parity, already two ones are there, then P1 is equal to 0. Okay. Now calculating P3 value. So now consider the MSB column. MSB column where the 1 is there. 1 is there at 4th position, 5th position, 6th position and 7th position. Okay. So now at 4th position, here P3 is there. In the 5th position, 1 is there. In the 6th position, 0 is there. In the 7th position, 1 is there. Okay. So that is P3 1 0 1. How many number of ones are there? Without considering P3, two ones are there. Two ones is nothing but 2. 2 is nothing but even parity. The message is sent with even parity. So by considering this one, P3 value 0, then it becomes a 0 1 0 1. So it is already two ones are there. Then it is sent with even parity. Okay. So therefore P3 is equal to 0. Here therefore P2 is equal to 1. Okay. Once we are calculating that P1, P2, P3 value, identify the error position. Identify the error position is equal to P1, P2, P3. What is P1, P2, P3 value? P1 value is 0, P2 value is 1 and P3 value is 0. What is the decimal equivalent? That is 2. Okay. So the error is located at second position. Second position in the message. Okay. In the message, the second position. So the total message we are required is, after calculating the parity bits, so 1 0 1. Next P3 value is 0, M1 value is 0, P2 value is 1 and P1 value is 0. Okay. So this is the second position. So the error is located at second position. Error is there. So to correct that error, change the bit from 1 to 0. So that is error correction. After correcting this error, so 1 is changed to 0. 1 becomes 0. So this is the error correction process. Okay, 1 can be changed to 0. Okay, so this is the final one. Okay, in this way we have to identify the error in the given message while adding the parity bits. For that purpose we have to use Hamming code. Thank you for watching this video. If you like this video, please share this video to your friends and classmates. If you like this video, please subscribe my channel name. So DIVVELA Srinivasa. Okay, here the error is located at second position. This is the second position in the given message. After calculating the parity bits, the error is located at in this position. Now this bit can be changed from 1 to 0 by correcting the parity bit value. Okay. After correcting the parity, after correcting that bit value, the message comes 1010000. Okay, so thank you for watching this video. Hi friends, today I am giving a lecture on example problem on Hamming code. Okay, so encode the data or message bits 0011 into the 7-bit even parity Hamming code. In the previous video, we are already discussing about what is Hamming code, how to detect the single bit error in the Hamming code, how to calculate the parity bits, how many number of parity bits are required, and how to correct the error after detecting the error in the given message by using Hamming code. These are the points we are discussed in the previous video. Now we have to concentrate on this example problem in this video. Here the given message is equal to 0011. How many number of bits are there? 1, 2, 3. Therefore number of message bits m is equal to 4. Okay. Next, number of parity bits required is calculated by using the following formula, that is 2 power p greater than or equal to m plus p plus 1. Here 2 power p greater than or equal to m value is 4. 4 plus p plus 1. So to satisfy this condition, what is the value of p we are getting? So suppose p is equal to 3, we are taking p is equal to 3, we are taking, then 2 power 3 greater than or equal to 4 plus 3 plus 1. So that is 8 greater than or equal to 8. So that is true. So the number of parity bits is equal to p is equal to 3. Okay. Total number of bits is equal to number of message bits plus number of parity bits, that is message bits is 4 and parity bits is 3, that is total number of bits is 7. Now these 7 bits can be represented in this form. This is LSB and this is MSB, and parity bits are located at the bit positions of powers of 2. That is 2 power 0 position, parity bit 1 is there. 2 power 1 position, parity bit 2 is there. 2 power 2 position, parity bit 3 is there. Total number of bits is 7. Among the 7 bits, 3 bits are located as parity bits. The remaining 4 bits can be located as message bits. So therefore total number of message bits plus parity bits is equal to 7. Now message bit value, so 0011, so this is LSB and this is MSB. So here MSB bit value 0, next one 0, next one 1, next one 1. Now we have to calculate the parity bit values P1, P2 and P3 values. Okay. Now P1. Now calculating the parity bit value. So P1. So we have to calculate the parity bit value P1 at 2 power 0. So now we have to consider the 2 power 0 column. So where the 1 is there. Here 1 is there at 1 position and third position and fifth position and seventh position. 1, 3, 5, 7. So that is equal to at 1th position what is there? Here P1 is there. Next at third position here 1 is there. At fifth position here 1 is there. At seventh position here 0 is there. So now here we are sent this message with even parity. Okay, but here how many number of ones are there? There are 2 ones are there. It is already even parity. So now by concluding that here P1 is equal to 0, 0, 1, 1, 0. So here P1 is equal to 0 to maintain the even parity. Now how many number of ones are there? 2 ones are there. 2 is the even parity by considering the P1 is equal to 0. Okay. So therefore P1 is equal to parity bit 1 is equal to 0. Now consider the P2. Here P2 is there at 2 power 1 position. Now consider the 2 power 1 column. In the 2 power 1 column where the 1 is there, so that is second position, third position, sixth position and seventh position. What are the corresponding values are there? At second position here P2 is there. At third position what is the value? 1 is there. At sixth position what is the value? 0 is there. At the seventh position what is the value? 0 is there. Here this message is sent with even parity. Okay. So here how many number of ones are there? Total number of ones is equal to 1. So it is a odd parity. To become the even parity, so now P2 is equal to 1. By placing 1 at P2 position, 1, 1, 0, 0. So now it becomes a even parity. So therefore P2 is equal to 0. Okay, because the message is sent with even parity, total number of ones is even number. To become the even parity, P2 is equal to 1. So now next parity bit P3. So P3 is there at 2 power 2 position. Now consider the 2 power 2 column where the 1 is there at 4th position, 5th position, 6th position and 7th position. Now what are the values are there? At 4th position here P3 is there. Next at 5th position 1 is there. At the 6th position 0 is there. At the 7th position 0 is there. Okay. How many number of ones are there? Only single one is there. To send this message with even parity, so total number of ones is equal to 1. To become the total number of ones is equal to even, so P3 value can be treated as 1. Okay. So therefore if P3 value is 1, 1, 1, 0, 0. So therefore total number of ones is 2. 2 is a even number. So therefore P3 is equal to 1. Okay. Next. Error position is equal to, by combining the P1, P2, P3 values. So that is P3, P2, P1. So that is equal to P3 value is 1, P2 value is 0 and P1 value is 0. So what is the decimal equivalent? So that is 4. 4 base 10. So therefore error is located at fourth position. Error is located at fourth position. Okay. So therefore, total message bits is equal to 0, 0, 1. P3 value is 1. P2 M1 value is 1 and P2 value 0 and P1 value is 0. The error is located at fourth position, this position. Okay. To correct this value, okay, we have to change the bit from 1 to 0. After correcting, the message bits are 0, 0, 1, 0, 1, 0, 0. Okay. So in this way, we have to solve the Hamming code example problem. Thank you. Thank you for watching this video. If you like this video, please subscribe my channel name. So DIVVELA SRINIVASA. DIVVELA SRINIVASA. Thank you. Hi friends. Today I am giving a lecture on example problem on Hamming code with odd parity. Okay, so this is the given problem. Encode the data or message bits 1001 into the 7-bit odd parity Hamming code. Okay, so now the given message is 1001. Okay. How many number of bits are there in the given message? There are 4 bits are there. 1, 2, 3, 4. So therefore M is equal to 4. Next, number of parity bits that are added to the given message is calculated by using the formula 2 power p greater than or equal to m plus p plus 1. Here 2 power p greater than or equal to, here m value is 4, 4 plus p plus 1. To satisfy this condition, suppose p is equal to 2, p is equal to 2 we have to take, then 2 power 2 greater than or equal to 4 plus 2 plus 1. So that is 4 greater than or equal to 7. So this is false. Okay. Now take p is equal to 3. So 2 power 3 greater than or equal to 4 plus 3 plus 1. So therefore 8 greater than or equal to 8. So therefore we have to take p is equal to 3. So p is nothing but number of parity bits. Number of parity bits is equal to 3. So total number of bits is nothing but number of message bits plus number of parity bits. Number of message bits is 4 and number of parity bits is 3. That is total number of bits is 7. Now these 7 bits can be represented from 1 to 7. This is LSB and this is MSB. In this 7 bits, parity bits are located at the bit positions at 2 powers. Here 2 power 0 is 1, 2 power 1 is 2, 2 power 2 is 4. So then at 2 power 0 parity bit P1 is located, at 2 power 1 parity bit 2 is located, at P2 power 2 parity bit P3 is located. So now we have to calculate the parity bit P1 at 2 power 0 position, P2 at 2 power 1 position and P3 at 2 power 2 position. Now what are the message bits? Here this is LSB bit and this is MSB bit. These message bits are M1, M2, M3, M4. Here M1 is 1 and M2 is 0 and M3 is 0 and M4 is 1. So these are the message bits and these are the parity bits. Now we have to calculate the parity bit values, that is P1. Parity bit P1. So to calculate the parity bits P1, before going to this one, okay, how many number of bits, total number of bits? That is 7. 7 can be represented as, so 2 power 3, approximately 2 power 3. So we have to use 3 bits to represent each and every bit from 1 to 7. So that is 1 to 7. So these 1 to 7 bits can be represented in the binary form by using 3 bits. So 1 is 001, 2 is 010, up to 7 is 111. Okay, we have to take 3 bits. Okay, next one. Here, to calculate the parity bit P1, so P1 is there at 2 power 0 position. Here this is 2 power 0 position column, 2 power 1 column and 2 power 2 column. Okay, so in the 2 power 0 column, where the 1 is there, 1 is there at 1 position and 3rd position and 5th position and 7th position. Okay, then what are the values at 1 position, 3rd position, 5th position and 7th position? In 1 position, the value is P1. In 3rd position, what is the value is there? That is 1. In 5th position, what is the value is there? 0. In the 7th position, what is the value is there? 1. Okay. Now we have to send the given message with the parity bits with odd parity. Here, these are the message bits and this is the parity bit. We have to send this total message with odd parity. Okay. Here, without considering P1, how many number of ones are there? There are 2 ones are there. Total number of ones is equal to 2. Then it becomes a even parity. But to convert this even parity with the odd parity, so now we have to take P1 is equal to 1. Whenever P1 is equal to 1, so the total message becomes 1101. How many number of ones are there? 3 ones are there. So then it becomes a odd parity. So therefore P1 is equal to 1. This is the first parity bit. Next, second one, calculate the parity bit P2. So P2 is there at 2 power 1 position. Here this is a 2 power 1 position, second column. So where the 1 is there, here 1 is there at second position and third position and sixth position and seventh position. 2, 3, 6, 7. Here what is the values are there at these positions? In the second position, P2 is there. In the third position, value 1 is there. In the sixth position, value 0 is there. In the seventh position, value 1 is there. Okay, how many number of ones are there? 2 ones are there. Total number of ones is equal to even parity. But parity bits and message bit, total number of bits that are sended with odd parity, but here even parity is there because 2 ones are there. To convert this even parity into odd parity, we have to take P2 is equal to 1. So whenever P2 is equal to 1, 1101 is there. 1101 is there. So therefore P2 is equal to 1. The second parity bit is a 1. Okay, next one. Now calculate the P3. Parity bit P3. So P3 is there at 2 power 2 position. So in the 2 power 2 column, where the 1 is there, here 4, here 5, here 6, here 7. 4, 5, 6, 7. So what are the values at these positions? At the 4th position, here P3 value is there. At 5th position, the value is 0. At 6th position, the value is 0.
At 7th position, the value is 1. Okay. Without considering the P3 value, so how many number of ones are there? Only single one. Single one is a odd number, then it becomes a odd parity. Here we have to send this message with odd parity. So therefore, already it is a odd parity, so then P3 value is equal to 0. Whenever P3 value is 0, then it becomes a 0, 0, 0, 1. So a total number of ones is equal to 1, then it becomes a odd parity. So therefore, P3 is equal to 0. Okay. Once after calculating the parity bit values P1, P2, P3, now we have to find out the error position in the given message. So error is located at, by clubbing all the parity bit values, that is P3, P2, P1. Okay, so what is P3, P2, P1 values? P3 value is 0, P2 value is 1 and P1 value is 1. 0, 1, 1, that is equal to decimal equivalent is 3 base 10. So therefore error is located at third position. Error is located at third position. Okay, so therefore total message including the message bits and parity bits, total message bits is equal to M4 value is 1, M3 value is 0 and M2 value is 0 and P3 value is 0, M1 value is 1 and P2 value is 1 and P1 value is 1. So this is parity bits and message bits combined. So now the error is located at third position. So that is first position, second position, third position. So here error position. Error position. Okay. So after correcting error, the message is correcting means whenever the error position is detected, so whatever the bit is there, the bit can be changed from 0 to 1 or 1 to 0. Here 1 is there, 1 can be changed from 1 to 0. So therefore 1, 0, 0. Here 1 can be changed to 0, remaining 1, 1. So after correcting the error, the message is this one. In this way, we have to solve the Hamming code example problem. So thank you for watching this video. If you like this video, please share this video to your friends and classmates. If you like this video, please subscribe my channel name. So DIVVELA SRINIVASA. Thank you.
Hi friends, welcome back to our YouTube channel. Today we have to discuss about Hamming code in Computer Organization course, Digital Logic Design course, Switching Theory and Logic Design course and Computer Networks courses. It is one of the most important concepts in the above courses. First of all, Hamming code is both error detection and error correction code. By using that Hamming code, we can detect the error also and correct that error also. Now we can go for one example problem. Generate the Hamming code for the given message 1000 sended with even parity. Find the error position of the received message if it received as 100 once. The given message is equal to 100. Number of message bits. That means we have to count the number of bits in the given message. So 1, 2, 3, 4. So 4 bits are there. Next, number of parity bits that can be appended to the given message can be calculated by using this following formula. That is 2 power p greater than or equal to m plus p plus 1, where m is nothing but number of message bits. So 2 power p greater than or equal to m value, already know that 4 plus p plus 1. For which value of p this equation satisfies? Now I am taking p value is 3. We have to assume that. So 2 power 3 greater than or equal to 4 plus 3 plus 1. So that is 8 greater than or equal to 8. Condition true. So we can say that therefore number of parity bits is equal to 3. 3 parity bits are there. So number of message bits is 4, number of parity bits is 3. Therefore total number of bits of the given message is equal to m plus p. So now m value is 4, p value is 3. So that is 4 plus 3, so that is equal to 7. Now we have to write the 7 bits. So that are 1, 2, 3, 4, 5, 6, 7. So these are the 7 bits. Parity bits are always located at 2 powers positions. What are the 2 powers positions among the 7 bits? That is 2 power 0, 2 power 1 and that is 2 power 2. In that locations parity bits are there. This is P1, this is P2, this is P4. And the remaining are message bits. That message bits are M1, M2, M3, M4. So once we are located the parity bits at 2 powers positions, the remaining bit positions are filled with message bits that are M1, M2, M3, M4. What are the M1, M2, M3, M4 bits are there? This is M1, this is M2, this is M3, this is M4. M4 value is 1, M3 value is 0, M2 value is 0, M1 value is 0. Okay, so these are the message bits. So these are the bits 1 to 7 and this parity bits location. Parity bits locations. And these are the message bits. Now we have to write the 7 bits binaries. Okay, for these 7 bits we have to write the binaries. So now this is 1 binary form is 0, 0, 1 and 2 binary form is 0, 1, 0. 3 binary form is 0, 1, 1. 4 binary form is 1, 0, 0. 5 binary form is 1, 0, 1. 6 binary form is 1, 1, 0. 7 binary form is 1, 1, 1. Okay, so 7 bits are there. So for this 7 bits we have to write in binary in 3-bit form, because here
number of parity bits is 3, so that we have to write in 3-bit binary form. Okay. Next, we have to calculate P1, P2 and P4 values. Okay. First, we have to calculate P1. To calculate P1 value, we have to consider the first column. We have to consider the first column. In that first column, where the ones are present. So ones are present at first position, third position, fifth position and seventh one. Okay. We have to calculate P1 so that this one is not considered, because we have to calculate for P1 so that this one is not considered. So now 1 is there at 3 and 1 is there at 5 and 1 is there at 7. Now what is the third bit value? Here we can go for the third one. What is the message bit here is there? That is 0. Exclusive OR. At fifth one, what is the message bit is there? 0. Exclusive OR. At seventh one, what is the message bit is there? 1. So 0 exclusive OR 0. 0. 0 exclusive OR 1. That is 1. So we can say that another way is 0 exclusive OR 0 is 0. 0 exclusive OR 1 is 1. Another way is the message is sent with even parity. Here in this one, how many number of ones are there? Only single one is there. To get the even parity, we are adding 1. Okay, this is the parity bit. This is another way to find the P1 value. Next, we can go for P2. How to calculate P2? For calculating P2, we have to consider second column. Okay, we have to consider second column. In that second column, where the ones are present, 1 is present at second one, third one, and sixth one, and seventh one. So we have to calculate for P2. So this one is not considered because we are calculating P2. So now 1 is there at third position and 1 is there at sixth position and 1 is there at seventh position. So what is the message bit at third one, sixth one and seventh one? At third one 0 is there, at sixth one 0 is there, at seventh one 1 is there. So 0 exclusive OR 0, 0 exclusive OR 1, that is 1. Here also we have to use another approach. The message is sent with the even parity. Here how many number of ones are there? 0, 0, 1. Single one is there. Single one is odd parity. To become the even parity, we are adding extra bit. This is the parity bit. Next one. Next we have to calculate P4. To calculate P4, we have to consider last column. So in that P4 column, so where the ones are present, 1 is present at fourth position, fifth position, sixth one and seventh one. Okay. Now we are calculating P4 so that this one is not considered. So this one is considered at 5 and 1 is considered at 6 and 1 is considered at 7. Now what is the message value at these positions? At fifth position, what is the message value? 0. At sixth position, what is the message value? 0. At seventh position, what is the message value? 1. So 0 exclusive OR 0, that is 0. 0 exclusive OR 1, that is 1. Here also how many number of ones are there? Single one is there. It becomes odd parity. To become the even parity, we are adding 1 extra bit. Once we are calculating P1, P2, P4, now we have to write the message. So this is actual message. So actual message is equal to, this is the bit pattern we have to use. M4, M3, M2, P4, M1, P2, P1. What is M4 value? 1. What is M3 value? 0. What is M2 value? 0. What is P4 value? That is 1. What is M1 value? That is 0. What is P2 value? 1. What is P1 value? 1. So 1 0 0 1 0 1 1. After adding these three parity bits, so the actual message is 1 0 0 1 0 1 1. Okay. Now what is the received message? So here received message is equal to, in the given problem we are given 1 0 0 4 ones. 1 0 0 4 ones. Now we are comparing the received message with actual message for identifying the error. That is called as error detection. Okay. Now this bit and this bit both are same. This bit and this bit both are same. And this bit and this bit both are different. Okay. This bit and this bit both are same. 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 So at third position, so count that position from the LSB to MSB. So at third position, we are getting the error. At third position, we are getting the error. Okay. First position, second position, third position. Now, how to correct that error? So, correct the received message. Correct the received message. How to correct the received message? At which position we are getting the error? At that position we are changing the bit value. So now 1 0 0 1. Here error is occurred at this position. Now we have to change the bit 1 to 0. 0 1 1. After correcting the error, what is the received message? 1 0 0 1 0 1 1. How many number of ones are there? 4 ones are there. Now it satisfies the even parity. The message can be sent with even parity. After correcting the error, the received message also contains the even parity. Here at this position we are detecting the error. Then we have to correct that error by changing the third position bit 1 to 0. Then we are getting the correct received message 1 0 0 1 0 1 1. So this is the procedure we have to follow for detecting the error and also correcting the error. That can be done by using a technique called Hamming code technique. So I hope all of you understanding this video. If you really understanding this video, please click on the like button and share this video to your friends and classmates. If you like this video, please subscribe my YouTube channel. So DIVVELA SRINIVASA. If you have any doubts, please put your doubts in the comment section. I will try to clarify your doubts. Thank you one and all for watching this video. In the next video, we are solving another example problem on Hamming code. Thank you one and all. Hi friends, welcome back to our YouTube channel. Today we have to discuss about Hamming code in Computer Organization and Architecture, Digital Logic Design course, Switching Theory and Logic Design course, Computer Networks. In these courses, it is one of the most important concepts that can be asked in several examinations. Now, in this video, we have to discuss about example problem on Hamming code. Before going to the example, first of all,
what is Hamming code, why Hamming code can be used. Hamming code is an error detection and error correction code. By using this Hamming code, we can identify the error position in the given message, and also we have to correct that error in the given message. Hence, we can say that Hamming code is both error detection and error correction code. Now, we have to solve one example problem on this topic. Generate Hamming code for the given message 1011 is sent with even parity. At the receiver side, the message can be received as 100101. Find out the error position and correct that error position. So the given message is equal to 1011. First of all, how many number of bits present in the given message, that can be denoted by M. So M is equal to 4. 1, 2, 3, 4. 4 bits are present in the given message. Next, how many number of parity bits that can be appended to the given message can be calculated by using the following formula. That formula is 2 power p greater than or equal to m plus p plus 1, where m is nothing but number of message bits. So that is m value already we know, that is 4, 4 plus p plus 1, where p is number of parity bits. How many number of parity bits we have to use for satisfying this condition? So let us assume p value is equal to 3. So 2 power 3 greater than or equal to 4 plus 3 plus 1. So that is equal to 8 greater than or equal to 8. So condition true. So whenever the condition is true, here p value is equal to 3. So therefore, number of parity bits is equal to 3. Okay. Message bits is 4 and parity bits is 3. So therefore, total number of bits is equal to m plus p. So that is equal to 4 plus 3, that is equal to 7 bits. So 7 bits are present in the message that are received at the receiver. Now, that 7 bits can be written in this form: 1, 2, 3, 4, 5, 6 and 7. So these 7 bits can be written from LSB to MSB, that is right hand side to left hand side. So these are the 7 bits. Next, where the location of the parity bits? The parity bits are always located at 2 powers positions. So 1 can be written as 2 power 0, 2 can be written as 2 power 1, 4 can be written as 2 power 2. So the corresponding parity bit is P1, the corresponding parity bit is P2 and the corresponding parity bit is P4. Once we have located the parity bits at the 2 powers positions, the remaining bits can be filled with the message bits. The message bits are, so this is M1, M2, M3 and this is M4. Okay, we know the message bits values. So that is M4 value is 1, M3 value is 0, M2 value is 1 and M1 value is 1. So this is M1 bit, M2 bit, M3 bit, M4 bit. we have to given the indexing from right to left. So M1, M2, M3, M4. Once we are locating the message bits, now we have to calculate the parity bits. Okay, so these are the parity bits. Now we have to find out the parity bit value. Okay, now so for each bit can be represented in the binary form. So 1 can be written as 001. In 3-bit binary we have to take. Okay, because 3 parity bits are there, so that we have to use 3-bit. 1 to 7. Okay, 1 to 7 means so 2 power approximately 2 power 3, so that we have to use each bit can be represented in 3-bit binary form. Next, 2 can be written as 010, 3 can be written as 011, 4 can be written as 100, 5 can be written as 101, 6 can be written as 110, 7 can be written as 111. Okay, once we are writing 3-bit binary form of each bit, now we have to calculate first P1. For calculating the P1 value, we have to consider the last column. We have to consider the last column. In that column where the ones are present, 1 is present at this position and this position and this position and this one. Okay, now we have to calculate P1 so that this one is not considered, because we are calculating P1 so that this one is not considered, the remaining ones are considered. Here 1 is considered at 3 exclusive R, 1 is considered at 5 exclusive R, 1 is considered at 7. Okay, next. At 3, what is the message bit value? So at 3, message bit value is 1 exclusive R. At 5, what is the message bit value? 1. At 7, what is the message bit value? 1. So now 1 exclusive R 1. So that is 0. 0 exclusive R 1. So that is 1. Here, without using exclusive or operation, we can also told another way, that is, how many number of ones are there? 3 ones are there. To become the even parity, what is the extra bit we have to add? So that is 1. 3 ones is odd number. We are adding another one as parity bit. Then the 4 ones becomes the even parity. So this is also used for finding out the parity bit. Next we have to calculate P2. For calculating P2, we have to consider second column. In that second column where the ones are present. So ones are present at second position, third position, sixth position and seventh position. Now we are calculating P2, therefore this one is not considered. So 1 is considered at third one, 1 is considered at sixth one, 1 is considered at seventh one. So what is the message bit value at third? 1 exclusive R. What is the message bit value at 6? 0. What is the message bit value at 7? 1. So 101, it is already in even parity, so that we have to append 0 as the parity bit. Another way, 1 exclusive R 0, that is 1. 1 exclusive R 1, that is 0. Next we have to calculate the parity bit value P4. For calculating the P4 parity bit value, we have to consider last column. Okay,
in the last column where the ones are present. 1 is present at 4, 5, 6, 7. We are calculating P4, therefore this one is not considered. Next one is at 5, 1 is at 6, 1 is at 7. Okay, what is the bit value at 5? 1. What is the bit value at 6? 0. What is the bit value at 7? 1. How many number of ones are present? 2 ones are present. Already 2 ones means 2. 2 means it is even parity. The message is also sent with even parity. Therefore, the extra parity bit can be appended is 0. Now, another way, 1 exclusive or 0. That is 1. 1 exclusive or 1. That is 0. Okay. So, now P1, P2, P4 parity bits values are already calculated. Now, the actual message. Actual message means the message bits plus parity bits. The message bits plus parity bits. Okay. So, that are this one. M4, M3, M2, P4, M1, P2, P1. These are the 7 bits. What is M4 value? 1. What is M3 value? 0. What is M2 value? 1. What is P4 value? 0. What is M1 value? 1. What is P2 value? 0. What is P1 value? 1. So this is the message that we are received at the receiver after calculating the parity bit values. Okay. Now, what is the received message or received actually? So that is received message in the given problem as the received message in the given problem as 1000101. 1000101. Now, at which position the error is occurred? For that purpose, we have to compare actual message with received message bit by bit. Now, first position both are equal, second position both are equal, third position both are equal, fourth position both are equal, fifth position is different, sixth position is same, and seventh position is same. Now, after comparing the actual message with received message, so fifth position is different. Here position value can be calculated from LSB side to MSB side. So therefore error occurred at fifth position. Error occurred at fifth position. Now, how to correct that error? Okay, now we have to write after correcting the error, the received message is at fifth position. Whatever the bit is there in the received message, that can be complemented. So now 1 0, here this bit value at this position error is occurred, so that we have to complement that bit. 0 can be complemented 1. Now 0 1 0 1. After correcting, what is the received message? 1 0 1 0 1 0 1. Okay. Now check the parity. How many number of ones are present? 4 ones are present, so that 4 is even number. So the message is received also with even parity. Okay. So this is the procedure we have to follow for finding out the error position by using Hamming code and how to correct that error. Okay. So I hope all of you understanding this video. If you have any doubts, please put your doubts in the comment section. I will try to clarify your doubts. If you really understanding this video, please click on the like button and share this video to your friends and classmates. If you really like this video, so please subscribe my YouTube channel DIVVELA SRINIVASA. So please refer the previous video. I already told another example problem on the Hamming code. Don't forget to subscribe my YouTube channel. Thank you one and all for watching this video.